Mr. Akshay Dev. He is Head of Business Development and Applied Businesses Data Center, Climaveneta India, a group company of Mitsubishi Electric. Coming with an industrial engineering background, he is also an MBA from Indian School of Business. He has over a decade experience in product knowledge, lean manufacturing, and supply chain of chiller brand systems for Climaveneta Mitsubishi. In addition to this, Mr. Akshay has a dedicated role on data center cooling solutions. Today, Mr. Akshay will give us a brief view on PUE optimization in data centers. So delegates, let's welcome Mr. Akshay.
So these are the 5 topics we'll speak about today. We'll talk about DC product range. What do we mean by specific DC product? What is the difference? We talk about, data center products. What is the difference between a DC product and a comfort application or a pharma product? So something in those lines. The only thing we'll speak about our organization is what are the capabilities and projects that we have done in DC, but we will not stress too much on this. The most important topic, all these that we have discussed, we want to know, or rather all the OEMs here or designers want to know what does a DC provider, someone who is, building a data center, what does he require from OEMs like us? Right? What specifically does it require from us? So this will lead up to answering the main question here. How do we optimize the PUE of a data center? So the first 4 topics will be like a background or a summary to arrive at the main question of how do we optimize a PUE? Okay. Let's start with a few questions, although we have not been having a live interaction, but I just want to ask 4 questions before we go ahead. Does anyone here know what is a percentage of HVAC load in a building, and how much is the percentage of HVAC load in a data center? I think, unfortunately for me, it was discussed in the previous presentation. So if anyone was, aware, and you can answer the question. Okay, since we are, we have a short of time program, so let me itself answer my own question, and then towards the end you can ask me the question. So, just to tell you this, that the percentage of HVAC load in a regular building ranges, if you see in ASHRAE and if you see the studies that we have done, it's somewhere in the range of 25 to 33%. And in a data center, it can jump even up to 40%, 45%, right? In some data centers, of course, not very efficient, goes even up to 50%. So you can understand the importance of this HVAC load. Why is this important? Why am I discussing this? It has a relevance to the PUE. Firstly, what is PUE? It's a term. Every product here, what we have presented today, has a benchmark in terms of what is the performance of the product. It could be COP in a chiller or a precision unit, whereas in insulation, it could be the thermal conductivity. PUE is like the measure of a data center, the efficiency of a data center. We call it as a power utilization effectiveness or power usage effectiveness. So why is it so crucial for the data center? Everyone talks about PUE. So, we've attended a lot of seminars from data center providers, and they tell us something very interesting. The better PUE that they have, they can claim to their end customers, the more they can demand from their end customers, right? In terms of contractually. So as an OEM, we have to understand why this PUE factor is so critical. Now, just a brief, not going into the specifics because we want to arrive at how to improve the PUE. These are the data center products. The column number 1 is we've split it into high side and low side just for easy reference. The high side is of course chillers, and the low side is nothing but at your server room level, which is your PAHU units. So today in the market, we have available up to 600 ton air-cooled chillers, COPs of up to 3.6. And we also have magnetic levitation air-cooled chillers with, again, similar COPs and capacities. We also have PAHU units and INRO units for hyperscale data centers. But this is just a brief overview for everyone here who has not worked in DCs to understand what are the products that go into a DC. We need to understand this. What is a DC product specifically? We keep saying, we make chillers, we make PAHU units, but what is so specific in a DC chiller? So first things first, let's talk about a wide operating envelope. In any data center, we need something. We've already heard from the flag group talking about a high operating envelope, which means we need a high chill water temperature. So data center chillers need to operate at a very high chill water temperature. Gone are the days where designers used to design at 7 degrees outlet, 8 degrees, 9 degrees. Now data centers are being designed up to 20, 22 degrees. So what does this do? In simple layman terms, it increases the efficiency of the chiller. In other words, it increases or betters your PUE, right? Or rather lowers your PUE. Okay, of course, we also need a high delta T. So delta T is nothing but the difference between your chill water out and in. So today chillers are equipped to operate up to 10 degrees delta T. So first thing, wide operating envelope. Let's go to the second one. We have a lot of agencies like Uptime, ASHRAE. We have a lot of designers, experts talking about redundancy. The data center needs to be designed with a lot of redundancy when it comes to any product. But what about within the chiller itself? Now products need to be, why a data center chiller is different from a regular chiller is that we even plan for redundancy within the chiller. So for example, if there are 2 compressors in the chiller, we plan in such a way that there are 2 compressors and 2 circuits, individual circuits, right? So we call it as NN configuration. So one 3 compressor model will have 3 circuits independent. So we cannot afford any chiller having downtime. So this is another key aspect you must look when you're choosing a data center chiller. Efficiency, PUE. So PUE is of course not for the product, it's for the data center, but efficiency. How do you identify whether your product is suited well for a data center? Of course, you have VFD options available. You need to ensure today the numbers in the market for a data center, the COPs are operating at about 3.6. But I would request everybody here not to focus too much on this number, the COP, because studies and statistics say that your data center is operating at full load. It never happens. Even in a regular building, it happens sometimes, but in a data center, it never happens. Why it doesn't happen, we can share it in another discussion. We are short of time, but anytime you want to reach out to me, I can explain to you in detail why the COP is not as critical as your part load efficiencies. So data center, typically studies are saying, even Uptime is saying that it's operating between 60 and 80% loading. So this is your number that is very crucial. So an air-cooled chiller giving you somewhere in this range of 6 kilowatt per kilowatt, or in terms of IKW, somewhere in the range of 0.58 to 0.6 IKW per ton in air-cooled chillers. So these are the numbers that you should be focusing on. Of course, variable primary flow systems in your chillers. So all your data center chillers today should be equipped with an inbuilt pump system, right? Because in a hyperscale data centers, you can have a huge volume of chillers, sometimes up to 10,000, 15,000 tons, right? Space can be a big constraint. So choose options which is having, inbuilt pumps and inbuilt variable primary flow. Okay, this again contributes to a lot of energy savings. In areas where there is humidity is less, you can also opt a DC data center chiller will also give you an option or a accessory as an adiabatic kit. We'll show you in the further slide what is an adiabatic kit. High ambient suitability. This question people ask me many times as to why does the data center chiller need to have high ambience? Why? Comfort chiller and data center chiller is the same thing, right? It is going in the terrace, whether it is any city, it's the city that is important. But why is it the ambient suitability needs to be high is because in a data center, especially in a hyperscale, we have something called as a lot of hotspot generation. So you can have places where there is a very concentrated area of heat. We are seeing in specific areas, even in a place like Bangalore or even Mumbai, where ambients typically don't go above 38, 39, 40 at worst. We are seeing hotspots being generated of 50 degrees, right? So you can't afford this. In a comfort application, you can have hotspots and your chiller efficiency will dip, but you cannot afford this in a data center. What else do you need? I was talking about space. You know how critical it is, especially with the hub of data centers in Mumbai today. Space is a very, very critical aspect. So look for chillers with inbuilt pumps. Today, most of the OEMs are having this. It's not that it's only specific to Mitsubishi Electric or our product. A lot of OEMs have started making this. Another thing is, we are continuing on what are DC products. So we are having automation. So inbuilt plant managers, gone are the days now. Customers are looking for internal plant managers itself. So basically nothing external to the system, less complicated, very robust and easy to use. So this is another evolution in the DC segment. This is a controversial statement, almost zero downtime. Of course, any customer will say they want zero downtime, but when it comes to a DC product, please ensure that you choose a product which has a quick restart. Gone are the days again where products used to start in around 300, 400 seconds. Today, you cannot afford it. The full load has to be achieved in 120 seconds, and your chiller should start in 30 seconds. Of course, now you're also having a very good technology where your DC specific products are having ATS, which is your auto transfer switch. So you're having a dual power supply. We already spoke about free cooling, I think, in the previous presentation, so I will not dwell too much on it. But there are options in DC chillers now with free cooling. Of course, look for certification. I kindly urge everybody, look for certification. People are forgetting about this basic aspect. This I will not spend too much time. Our capabilities in a data center. Just want to tell you, as Mitsubishi Electric Group, we have already executed 41 data centers till date. And fortunately, in the last 2 years, we have the highest market share when it comes to chillers in data center. We have achieved about 33% market share. But again, we are not talking about our company specific now. We will go straight away into the main topic. What does a data center customer want? See, this is a question based on which we have spent a lot of time on R&D, and I'm sure all OEMs are doing this and designing their specific data center product based on these questions. First, most no-brainer question is what does the customer want? He wants the highest uptime. He does not want any downtime on his equipment. It's as simple as that. It can lead to millions and millions of dollars of loss. One credit card transaction that you are swiping today as a customer, and imagine your data center is down, just imagine if there are millions of people in the world doing this. So that's how critical it is. So no downtime. So what do you do in terms of a product? Make sure the product is redundant internally, not just spending more money by the customer adding more and more chillers, but internally the product has to be redundant. So as I told you earlier, number of compressors, number of circuits, you need a quick start. So when there is a power failure, you need the chiller to come on in 30 seconds. Every customer is looking for a buffer tank management, because no matter how much redundancy you put, you need to have a buffer tank. When there is a power failure and restoration, you need to have a buffer tank. So the company you're choosing, please ensure they have expertise in buffer tank automation. Best PUE, of course, customer will say, I want the best PUE, right? Because that is what amounts to him getting a capital gain in there. So chill water temperatures, how do you get best PUE? We spoke about this. Higher chill water temperatures equals better efficiencies. Adiabatic kits in places, especially where there is less humidity, places like Bangalore, Hyderabad, dry climates, very, very useful to increase the chiller. Inbuilt variable primary flow systems, your pumps, active redundancy automation. Of course, a customer is saying he wants a fast and reliable service. Please demand this from the OEMs. Being an OEM, I may be shooting myself in the foot, but today, we can't have any low response time. So make sure you get an OEM who is committing to you contractually. What are the response times? Fail-safe automation. So not just the products, but even the automations are on standby these days. So this is what the customers are looking for. Interruption-free cooling, again, very important. At the server room level, a customer will tell you that he wants a tolerance of plus or minus 1 degrees only, right? This is something very critical. So technical support and system design knowledge. So a product manufacturer should also have in-house automation and system expertise, not just the product. So he should be able to know the entire system and ensure he can take a single point of responsibility for the chillers and high side equipment, right? The entire chill water supply has to be a single point responsibility. We just spoke about this. So now all OEMs are committing this. So data center specifics, it is one thing to test a product in a lab and one thing to test it in the field. So although I'm sure every customer asks for a testing in the lab, please insist on a site testing. Okay, and of course, every customer is also looking for a financial stability because these are very large projects. So I will just reduce the volume here, but we just wanted to summarize all these things to come to the final and most important topic. How do we optimize the PUE? Number one, choose high delta T chillers. Choose high chill water temperature chillers. Okay, this is the first point here. Again, I'm telling you, it's not only specific to our product. Whoever you go with, make sure you get this. This is one of the most critical aspects when you're choosing a DC product. If people are not about to provide you this, it means that they're giving you a product which is suited for another application and trying to fit it into a data center. Number two, all chillers must be working. There is a concept called active redundancy. I'm sure maybe some people have heard, some have not, but active redundancy, the old school method is if you have 3 chillers, 2 will be working, 1 will be standby. Please forget about this system. This does not exist today anymore. All chillers need to be working. All chillers need to be running at partial loads and ensure that you get the combined best efficiency. And all the controllers will take care of this, so you don't have to worry about that. I told you, variable primary flows. Insist on variable primary flows. These are, there are a lot of system designers who have apprehension to this, but if you are getting a chiller manufacturer who can take single point responsibility with inbuilt pumps and he will take control of the chill water system, variable primary flow studies have given, and we have written data on this, that you can save even upward of 15% in your pumping energy. It's a big saving. And finally, we spoke about adiabatic kits. As you can see, these are chiller. Adiabatic kits are nothing but having a misting system on the condenser coils of chillers. You can have this in any of your chiller equipment. Of course, please do not choose this in ambients which have very high RH. It may not be very useful to you. So in a summary, I would say, these are the 4 things that you should look for when it comes to chillers, which will lead to your PUE optimization. And thank you, Thermal Control Magazine, for this opportunity.